So now that we understand host, we understand why we want to do open architecture and what it is, how can we utilize it? And we'll go through both a new acquisition and even how to apply it to some legacy system. So leveraging host in your acquisition. First, to leverage it in a new acquisition. So open standards, they ease the process for making sure a system is leveraging MOSA following the MOSA initiative to the DoD. It does that by having a very standard set of requirements that vendors and integrators need to meet. And when you know that based on the tier 1 architecture that all these requirements flow under, if you meet all the requirements, you will have an open architecture solution that gets the benefits of open architectures. So how can you require this in your acquisition effort? Host really makes this fairly simple from a requirements perspective. Right? It can have, first you would want to require that each module in a system should follow a host tier 3 specification. So every module has a tier 3 specification. That means every module uses a tier 2 interface, and every module's performance and interface definitions are open and available to the government. And then also there are some system level requirements, such as what kind of communications can go between these modules. And so you would have a second requirement saying systems shall follow all system requirements as denoted in the host OpenVBX tier 2 HOVM. So the HOVM and then the CVAM within the HOVM actually has specific system level requirements as well. And with those two, you now have a system that follows and meets the tier 1 concept. And then you have a bunch of modules that meet the tier 1 concept. And so again, there's still responsibilities of the acquisition authority. That's not all that needs to be done. You need to make an effort to reuse pre-existing tier 3s if possible as well. And then you can also incorporate open architecture into a legacy system built before these standards existed. And we'll run through an example just to highlight how that can be done. So let's say there's a new platform that requires an upgrade, and we'll use the IDM, the Army IODM 401 as an example of data modem. And the upgrade needed would be an obsolete processor. Maybe you want to go from single core to multi-core, or the processor is just obsolete. And then you want to increase bandwidth in communication between the modules. So you go in, you look at your legacy system. It's a 7-slot chassis. It's based on an old technology, compact PCI. And you have your obsolete SBC. You have an I/O module, such as similar to peripheral modules that we spoke about earlier. You have Ethernet switching for communication and power supplies. What are some of the constraints of this design? Well, one, and the major constraint is you got to keep the chassis form factor and I/O the same. The platform isn't changing. The gap that the chassis is going to fit to is not changing, and the cables aren't going to change. The signals aren't going to change. So you need to make sure the form factor and I/O are the same. Also, this legacy system, it utilizes non-standard user-defined pins for primary communication. A lot of times when you look at these legacy systems, even though they may follow some type of technology, some COTS technology such as compact PCI, the pin definitions aren't that great, or they only define a subset of the connector. And so they'll use a lot of user-defined pins between different modules. And so they're really tightly coupled together because you don't have insight into those interfaces, as a new integrator won't have insight into those, and the acquisition authority may not have that data. And in this case, all modules are from the same vendor, so they make sure they can tightly couple them together. But there's also that serial I/O board, and that's specifically designed for the system I/O, so that interfaces with all that platform-specific I/O. Now you're going to want to say, during this upgrade, what components should we upgrade? You probably want to upgrade the maximum benefit components and things that will change constantly in the future. So that would be your single board computer, your Ethernet switches for bandwidth, and then potentially power supplies will need to be changed just because newer processors, newer switches require more power. But some things that could stay the same, you're not changing the external I/O, you're not affecting that. So you might want to keep the serial I/O board the same because you're going to have to get it spun specifically for your needs anyway. So now you want to go in and define the interfaces for your system. And how are you going to do that? Well, first you do a market survey to see what kind of technology is available that could potentially fit into your design space. And you see VPX is similar and also has a larger market share than compact PCI. And then you also can see what open standards leverage VPX technology, and you see hosts. So you see that there's an open standard leveraging VPX that you can now push for in your legacy system upgrade. So what does that upgrade look like? So you go through the design, you pick modules, and now you have a new, more open hosts legacy, or your next upgrade to the legacy system is following the host standard. So what you've done is you've been able to update the SBC using the payload profiles. You've been able to update the switch to one of the switch profiles. And you've been able to use one of the Vita62 power supplies that are further defined in host. And so all these are now 3U host open VPX modules. They all have tier 3s that follow them. If you know a little bit about compact PCI and VPX, the VPX has larger pin density. So you're able to put all that data communication on a single module instead of having 2 different Ethernet switch modules. So you're able to aggregate all that into a single Ethernet switch. And you get to higher speeds offered by the OpenVPX connectors. The wafers allow for higher speeds than the compact PCI pins. And each of these are all COTS modules because they're all following the interfaces defined in host. But the chassis size stays the same because the form factors are very similar. And you're able to, in your backplane, actually just keep the legacy compact PCIO. Yes, that will require a little bit of a non-standard routing within your backplane, but really just that one module is unaffected, and that one module, the IO module, is going to be more difficult to upgrade in the future, but that's also not going to be upgraded that often or at all because of how it would affect the interface to the external platform. And so you end up having 2 spare slots, which you could for future use, and then you have your open COTS host hardware as well. And that's how you would incorporate host into a new or legacy acquisition. So if you need further information, the first place to go would be check out the hostoa.com website. You can get all the latest publicly available host standards. There's additional host documentation. There's additional host resources. And there's also news and events. Again, we want to thank PMA 209 for our sponsorship, and also all the great GTRI engineers that have been involved in the host program. You can contact Navair PMA 209 at aat.fct@navy.mil, and you can contact the head of the host at the GTRI side, which is Christopher Schnell, and that's christopher.schnell@gtri.govtech.edu. So yeah, thank you for attending.